So now we're going to look at the situation where sigma is unknown. So again, we're constructing a confidence interval for a population mean, mu, and sigma is unknown. So sigma is unknown. Okay, and if this is the situation, then we use a student t distribution, which you can see here. You're using t critical values instead of z critical values, s instead of sigma within your formula. This is your formula for your margin of error. This is your confidence interval. If you're using your calculator trick, then you're going to t interval instead of z interval, t interval. So let's look at a couple of examples. This one is in the Triola book, page 328, number 10, birth weights of boys. So we have used the summary statistics for birth weights of 195 boys. So they're just directly giving us stuff. 195 boys. That is our sample size. Now it says X bar is 32.7. So this means that we have our sample mean. So from the sample, their average is 32.7. S from the sample, the standard deviation, sample standard deviation is 6.6. So from the sample, using 95% confidence level, we want a 95% confidence interval for the population mean, for mu. So this would be our point estimate if you want to think about that, right? We're using a sample mean to approximate a population mean. And we want a 95% confidence interval for this case. So first of all, if it's a confidence interval for mu, I have to consider whether or not sigma is known or unknown. Now, because I'm given S instead of sigma, then sigma is unknown, and that tells me that I'm going to use t interval instead of z interval. Okay, so now when I go to my graphing calculator, let's clear this out. Again, I'm going to go to stat again. This is where I'm going to find it, over to tests. And z interval is number 7, but we don't want that. We want t interval, which is right underneath that. So again, be very careful which one you're going to use. And again, it has data and it has stats, but we don't have data. We don't have a list of values, so we're going to stats. And notice that it asks for X bar, S, X, and N. So obviously, it kind of like basically tells us what to do. I use t interval for S. I use z interval for sigma. Your calculator kind of asks for exactly what you would need for t versus z. So S for t. So let's put it in. X bar, my sample mean is what? 32.7. So 32.7 is X bar. X, my sample standard deviation, 6.6. N, my sample size was 195. And my confidence level for this case is 0.95, 95% confidence level. Calculate. I got in interval notation my interval of values, so 31.77 is my low end, 31.77, and then my higher end is 33.63. What the heck? 33.63. This is my 95% confidence interval estimate for the average in this case between 31.77 and 33.63. So again, we're going to say we are how confident? This is pretty repetitive. I mean, you get this. We are 95% confident that the true value of the population mean, in this case, let's say we're not sure what this is from, for birth weights, of the average birth weight of boys is between 31.77 and 33.63, and our units are Hg. Okay. So again, this time they gave us the summary statistics, which is nice. They don't always do that. In this case, you know, they might say, if they didn't directly give this to us, 195 boys have an average birth weight of 32.7, and a standard deviation of 6.6. So that would imply that the standard deviation comes from the sample. Otherwise, they would separate it. So the birth weights of 195 boys is an average of 32.7, and then the standard deviation for the population would be 6.6. That would tell you that you're using sigma instead of S. I want to show one more example, especially something like this, which is a little bit different. This is in, again, the Triola book, page 329, number 16. Listed below are the amounts of arsenic in samples of brown rice from California. Use a 90% confidence level for the average. So we're doing a 90% confidence interval estimate for mu. Again, once you determine that you're doing a confidence interval for mu, you have to think about whether or not sigma is known. Now, they don't really give us anything but a list of numbers. So this is our sample. So obviously sigma is unknown because they don't give us anything outside of the sample. They don't give us the population standard deviation for this situation is this. They just give us a sample. And from this sample, we have to determine everything else. So we're going to again use T interval to do this. Now, maybe you guys already kind of determined, because I have a list of numbers, there's a little bit of a difference, you know, when I go into the graphing calculator. If I go to stat and over to tests, and let's go down to T interval, you guys can imagine this time I don't have the stats given to me. I don't have X bar. I could find it if I want to for this, but to make it a little bit easier, we're going to go to data this time because we have a list of numbers. Now you see that it asks for the list the numbers are located. So we have to actually tell it where that list is. So that means we have to input the list into our calculator before we can actually use this portion. So I'm going to quit this second mode to go back to my home screen. And if you guys remember how to find how to input a list of numbers, we go into stat and then edit, and put it under whatever list you want. I'll put it under L1. Just remember where you're putting it. So 5.4, 5.6. So I have 5.4, enter. 5.6, enter. 8.4, 7.3, 8.4, 7.3, 4.5, 7.5, 1.5, 5.5, 9.1, 8.7, 9.1, 8.7. So again, because we're given a list of numbers instead of the actual, statistics, I'm going to have to go and input those values into a list first. Now I can go back to stat, over to test, and down to T interval because I don't have sigma. Enter. And now I'm under data. I could tell it where the list is. It's in L1 on mine. You know, if I had to change that, let's say it was under L2. L2 is above the number 2 here. I'd press second 2 and L2 would come up. But again, mine is in L1, so second 1 to pull up L1 here. Frequency is 1, leave that as 1. C level is 90%, 0.9. Down to calculate, enter. And then it does the same thing. The nice thing also is that it gives me the mean of the sample and the standard deviation if I wanted that. So I actually am not only given the interval, the confidence interval, but I'm also given x bar, which is 6.35, and s x, the sample standard deviation, 2.32 micrograms. Now, it also says n is equal to 10, but I can determine that by counting how many are in the sample size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My confidence interval for this case has a low of 5.0 if I round to 7.7 if I round micrograms. This is my confidence interval estimate for this particular situation for the average here. So again, here we go. We are how confident are we? We are 90% confident that the true value of the population mean, or the, let's see what this situation was about, the mean amounts of arsenic, true value of the or average amount of arsenic for the population is between 5.0 and 7.7 micrograms. Okay, so this part is pretty repetitive. You actually can just get this from the problem directly. So, and then this is my confidence interval. So, I mean, they ask a little bit more. This is for California specifically, so this population probably comes from California. So I wouldn't say that it would be a good estimate for Arkansas, but for now we're just determining the confidence interval.